Stewart's theorem. M times A times N plus D squared times A equals B squared times M plus C squared times N. Also known as a man and his dad put a bomb in the sink. That's one way to remember it. Here's the proof for Stewart's theorem. First of all, looking at angles A and B, you can tell that they are supplementary, meaning that the cosine identity can work with this. Cosine identity is where supplementary angles, theta and 180 minus theta, are in here. So using that can apply to cosine alpha and cosine beta, which leads to equation 1, cosine alpha equals minus cosine beta. To find cosine alpha and beta, you can just use the law of cosines, making cosine alpha equal d squared plus n squared minus b squared divided 2dn, and cosine beta equals d squared plus m squared minus c squared divided by dm. You can put equation 1 into equation 3, making it so cosine alpha equals c squared minus d squared minus m squared divided 2dm. Now you can just subtract the two equations, 2 and 4. Two and 4 will equal to d squared plus n squared minus b squared equals c squared minus d squared minus m squared. Oh yeah, right, forgot, whoops. Divide by 2dn, divide by 2dm. There we go. Now let's multiply. First of all, let's cancel 2d on both sides and multiply both sides by mn. That leaves us with d squared m plus mn squared minus b squared m equals c squared n minus d squared n minus m squared n. Let's combine like terms. You can tell that mn squared and m squared n both have the common thing of mn. So if we put them on one side, we can put these on one side, b squared m plus c squared n, and put m and m plus m. And you can also put d squared n plus m. You could tell that because this went on that side, on the left side, and this one on the left, and this one on the left side, and this one on the right side, to clear things up. Well, since n plus m equals a, that means mn times a plus d squared times a equals b squared m plus c squared n. And that is Stewart's theorem. If you just have rearranged the letters a little bit, the variables a little bit, you'll just be able to find that this equation equals this one.